So in this video, I'll be going over some problems on converting Riemann sums to definite integrals to Riemann sums, so both directions. If you're in AP Calculus, this comes up quite often in the multiple choice, converting between the two representations. And if you're in calculus at a community college or university level, this is a common type of question that you'll get on midterms or the final exam even, all right? Okay, so let's begin. Let's recall the definition of a definite integral, okay? I'm not going to go over the derivation and all that. I'll briefly go over the concept once more. But here it is. It's the limit as n goes to infinity, summation as I goes from 1 to n, f of x of I, delta x. This is equal to the definite integral from a to b, f of x dx, okay? So this is where I'll briefly recap. If you remember, right before you learn this definition, you learn how to approximate integrals with rectangles, area under the curve using rectangles, I should say, the left endpoint, the right endpoint, the midpoints, and all that stuff, maybe even the trapezoid method. Yeah, so this is what's happening on the left-hand side here. F of x of I is the height of each of those rectangles, and delta x is the width of each rectangle, okay? Or the base times height. So these are the two dimensions, okay? And if you remember, the area under the curve becomes more accurate as you increase the number of rectangles, meaning the width of the rectangles decrease, okay? So that's why n is approaching infinity. The number of rectangles increases, and as a result, the width of each rectangle decreases here, okay? And this x sub I, there's multiple ways to represent this summation notation. Actually, this is using the right endpoint. So we start at A, okay, which is the very left of the interval. And then we go in increments of the delta x, the width of each rectangle, and I is the ith rectangle. So we start from I as 1. So that's why it's the right endpoint, A plus 1 rectangle width. If you do left endpoints, I believe this is I is 0 and this is n minus 1. So it's very similar. But how I remember is this right endpoint representation, okay? Okay, let's move on. So let's go over some examples going from the definite integral to the Riemann sum representation. This is a little easier most of the time. It's the other way around that gets most of my students in trouble, okay? They're not flexible enough to go both ways. So let's go the little easier way first, and then we'll go the other way. Okay, so this is a very common integral that comes up as the example to start with. Integral from 0 to 1, x squared dx. So we want to get the pieces out first. Okay, so this is the definite integral representation, a to b, f of x dx. Okay, so a is 0, b is 1, f of x is x squared. We get the pieces. So now we calculate delta x, which is b minus a over n. B is 1, A is 0, so that's just 1 over n. And after we get delta x, we can find x of I, which is A, which is 0, plus delta x times I, which is just 1 over n times I. So now we plug in the pieces into the limit definition over here. So f of x of I, this is our f of x, right? X squared, so wherever there's an x, replace it with this x of I, so it becomes 1 over n times I, quantity squared, and then times delta x, which is 1 over n. That's it. Okay, I didn't bother simplifying. This is usually good enough. At least for me, it's good enough. Okay, it depends on your teacher. All right, number 2, we have natural log here. Integral from 1 to 9 ln of x dx. Okay, so we get the pieces again. F of x is natural log function. A is 1, b is 9. Calculate delta x, which is b minus a over n, which is a over n. And then we find x sub I afterward. That's 1, a is 1, plus delta x, which is a over n, times I. Now we plug in the pieces into the definition. F of x sub I, so our function is natural log x, so wherever there's an x, plug in x sub I right there, okay? And then times delta x, a over n. Okay, hopefully, as you see, this is the easier way. As we practice a few, you'll get a hang of it quite easily, hopefully. Okay, example 3, here's a trig function, integral from pi over 2 to 3 pi over 2 sine of x dx. Our function's f of x, a is pi over 2, b is 3 pi over 2, delta x is b minus a over n, so 3 pi over 2 minus pi over 2, that is 2 pi over 2, which is just pi, so pi over n is our delta x. And x sub I is a plus delta x times I. That's right here. Okay, plug in the pieces. I won't go say everything. Here it is. Okay, so hopefully you see the pattern here. Example 4. Here's the absolute value function. Do we get intimidated by this? No, we do not. It's actually very straightforward still. Get the pieces as we did before. F of x is absolute value x. A is 1, B is 3. Delta x is b minus a over n, which is 2 over n. X sub I is a plus delta x times I, which is 1 plus 2 over n times I. Okay, and then nothing intimidating about this. You just plug in as before. Our function is absolute value x. We replace x with x sub I right there. And then times delta x. Nothing special about it. So don't get intimidated when this is the absolute value function. Okay, now let's go the other way around. So I'm going to use the same example of the integral from 0 to 1 x squared dx first, okay? So this is what we had before. Okay, now we have to go back to this one in blue over here. Okay, so we got to break up the pieces again. So let's recall the definition first. Limit as n goes to infinity. Summation as I goes from 1 to n, f of x of I delta x. So we could probably make a good guess that delta x is 1 over n, okay? Which is b minus a over n. And then f of x sub I is this guy over here, this other piece over here, okay? And x sub I is a plus delta x times I, okay? So we could probably make another good guess that, well, actually, I should say that you could let a and b be a lot of things, but usually let's keep it simple. And then our f of x can be a lot of things as well, but I'm trying to keep things simple. Okay, so if we let a be 0, okay? So if a is 0, we need our delta x to work. So that means b must be 1. 1 minus 0 over n, that's 1 over n, right? So that would work out, okay? And if a is 0, that would work out that delta x times I is 1 over n times I quantity squared. Okay, that's what I'm saying over here. Okay, so we got all the pieces. We got a, we got b, we got f of x. So we can write it as the definite integral from 0 to 1, x squared dx. Okay, hopefully that makes sense. As you can see, this way it's a little more complicated. You got to be able to kind of make an educated guess as to what your delta x should be. Usually it's some multiplier, like this factor over here, and everything else is something to do with the function. It's the f of x sub I, okay? Okay, if this wasn't super clear, hopefully a few more examples can help you see the process of how to think through it, okay? So example 2, limit as n goes to infinity, summation as I goes from 1 to n, square root of 4 plus 16 over n times I times 16 over n. This is our limit definition, remember? So let's make a guess that this delta x is 16 over n, okay? And then we're going to guess that this other piece over here is our f of x sub I, okay? Which is square root of a plus delta x sub I, okay? In this form. Okay, so if we let a be 4 to make our life easy, okay? And then that means if a is 4, what minus 4 is equal to 16? That is 20, so b would be 20, okay? And therefore, our f of x is square root of x. It would work out, okay? Therefore, we have all the pieces now. We can write the definite integral from 4 to 20, square root of x dx. So once again, hopefully you see the thought process I have. Pick a delta x. Usually it's a simpler thing, to be honest. Okay, you probably want to keep it simple as well. Delta x is probably this piece. Everything else is the f of x sub I. And then you start undoing the pieces and make your life easy. Like you could let a be 0 technically if you really wanted to, but make your life easy. A is 4, and then everything else is easy to piece out. If a is 0, then your b will be some not nice number at all, probably, and your f of x might be a little different as well. Okay, so try to keep your life as simple as possible and make these simple guesses like that. All right, example 3. We have this limit as n goes to infinity, summation as I goes from 1 to n, e to the 1 over n times I, this is on the exponent, times 1 over n. Okay, so we guess that delta x is 1 over n, and therefore f of x sub I is e to the 1 over n times I, okay? And so we probably want to let a be 0, so then b would be 1 from this delta x definition, okay? And f of x would be just e to the x. We have all the pieces, so the integral is 0 to 1, e to the x dx. Okay, example 4. This is actually on an exam from UC Berkeley. Okay, they had to actually evaluate the integral at the end, but they had to do this process in order to get this definite integral representation, which is much easier to calculate than this summation over here. Okay, so we have this complicated thing over here. So since it's more complicated, let's try to focus in on what is possibly the easier portion first. It's probably a good guess that sine of maybe x squared is part of the function. So this is probably our delta x sub I, 2 plus, not delta x sub I, sorry, our x sub I, 2 plus I over n. Okay, so let's make that guess first. If this is our x sub I, that means a might be 2. And if a is 2, b is 3 then, because this is a plus delta x times I. And delta x is b minus a over n. Okay? So that's why b is 3. So I didn't write that here, but that's what my thought process was. So because of that, delta x is 1 over n. And x of I, yeah, as I was saying. Okay? 2 plus 1 over n times I. Okay? So this is giving us a good momentum to finish this problem now. Because let's now rewrite this summation, what's inside the argument of the summation. That's the right terminology. What's inside the summation, I should say. Because that makes more sense, okay? In more of this form, f of x of I times delta x. We guess that delta x is 1 over n. So let's factor out a 1 over n from this other term over here. Okay? So we get 6n plus 3i over n remaining, and then sine of that guy, and then times 1 over n. Okay, now this looks much better because this first term, we can factor out a 3, and it becomes 2n plus I over n. And if we divide through by the n, it's just 2 plus 1 over n times I. That's our x sub I. Okay, so this is just 3x sub I sine of x sub I squared times 1 over n. So we now can get our entire f of x. It's just 3x sine of x squared. Okay, and then we have all the pieces. So I wrote it here. So the integral is from 2 to 3, sorry, 2 to 3, because our a and b we found earlier here. And that's our definite integral. Okay, so hopefully this is a good example to see how to break up the pieces and make educated guesses, making your life simple with those guesses. Okay, now let's do some multiple choice problems. I've just found the PDF online that some teacher posted. I take no credit for this. So we have this integral from 0 to 5, 3 minus x squared dx. Which one is the correct Riemann sum? So go ahead and try this on your own first. Pause the video and try it. Okay, so we need a delta x, which is b minus a over n, so that's 5 over n. X sub I is a plus delta x times I. A is 0 plus delta x, which is 5 over n times I. Okay, so f of x sub I is, our f of x is right here, so it's 3 minus 5 over n times I quantity squared. Okay, so this is our limit definition. We plug in the pieces. That's answer B, choice B. How about this one? Limit as n goes to infinity of this big guy over here. Which one's the definite integral? Okay, so hopefully you tried it on your own. We could probably make a good guess that our delta x is 1 over n. Okay, and this is our f of x sub I, this thing in the brackets, square brackets over here. Okay, so if delta x is 1 over n, we let a be 0, because it looks like it's 0 plus delta x times I, okay? Which means b equals 1 then, since delta x is b minus a over n. If a is 0, b must be 1 then, okay? And x sub I is 1 over n times I, so it looks like our function is 2x to 2/3 power. Let's double check. Because remember, our summation starts from I equals 1. So when I is 1, we get 1 over n right here. When I is 2, we get 2 over n right here. When I is 3, 3 over n right here. So on and so forth, okay? So it looks like we're good. Therefore, our answer is we have all the pieces. Integral from 0 to 1, 2x to 2/3 dx. Okay. Number 3, this expression is a Riemann sum approximation for which definite integral? Okay, hopefully you tried it. So again, let's try to get our delta x first. That would probably be this term over here, 2 over 25. So if we let a be 0, then b would equal to 2 then, because again, delta x is b minus a over n. How did I choose a as 0? Well, this is our f of x of I, and x of I is a plus delta x times I. I don't see like a something plus something, or unless they simplified everything. So let's make our life easy, as I keep saying. A is 0, then b is 2, the delta x that we have. So our x of I is 2 over 25 times I. Okay, because the x of I is a plus delta x times I, as I said. So that's 2 over 25 times I. And let's double check. If I is 1, 2 over 25. I is 2, that's 4 over 25. I is 3, 6 over 25, so on and so forth, right? So we have all the pieces now. It's the integral from 0 to 2 square root of x dx. That's choice B. How about this one? If n is a positive integer, then this limit can be expressed as which of these definite integrals? Okay, hopefully you tried it. Again, let's probably pick delta x to be 1 over n. Now this case, because I see it something plus 1 over n in this very first term, maybe let's let a be 1. And since delta x is b minus a over n, if a is 1, that means b must be 2. You get 2 minus 1 divided by n to be 1 over n, okay? Okay, so x sub I is 1 plus 1 over n times I. Okay, let's double check again. I is 1, that's right here. I is 2, that's 1 plus 2 over n, right here. I is 3, that's 1 plus 3 over n, that's right here. Very good. So f of x is 1 over x. Okay, and therefore we have all the pieces. We have a b, a f of x. This is our definite integral. 1 to 2, 1 over x dx. Number 5, if n is a positive integer, then this limit can be expressed as which one? Okay, so hopefully you got the pattern. Delta x is probably 1 over n. We let a be 0, which means b equals 1 from our b minus a over n. And therefore, x of I is 1 over n times I. Okay, let's double check. If I is 1, 1 over n. I is 2, 2 over n. I is n, that's n over n. I is n, yeah, this would work out. This is probably like left endpoint definition. Okay, but anyway, so our answer is, we have all the pieces, integral from 0 to 1, x squared dx. Okay. I don't know. Okay, my audio seems like it's working again. Okay. Sorry about that. Problem 6. Now we'll scroll down to the last one. This expression is a Riemann approximation for which these integrals. Hopefully you got the pattern now. Whoops. Wrong way. Delta x, we let 4 be over 50. If a is 0, then b is 4 then. X of I is 4 over 50 times I. So f of x is e to the x then. Okay? Again, I is 1, we get 4 over 50. I is 2, we get 8 over 50. Seems like it works out right. Therefore, the answer is choice A, integral from 0 to 4, e to the x. Yes. All right, that's it for this video. Hopefully this was good practice, or if you were not clear about how to push these problems out, hopefully I explained my thought process and that helps you out. All right, please give this video a like if it has helped you in any way. It really supports the channel. Hopefully see you in another video as well.